Let us solve OpenStax University Physics, Volume 1, Chapter 2, Problem 65. The vector d is 2.0 I hat minus 4.0 j hat plus 1.0 k hat meters. We need the three angles it makes with the x, y, and z axes. A three-dimensional drawing is helpful for checking signs, but perspective drawings are not precise enough to measure these angles. We will use the drawing for meaning and the dot product for calculation. Draw a right-handed set of axes and track the component signs. D has a positive x component, a negative y component, and a positive z component. In the perspective view, the dashed path shows those component moves. Looking from the positive x direction collapses the x component, leaving a projection that points toward negative y and positive z. These views help us predict that the y-axis angle should be obtuse, while the x and z-axis angles should be acute. The dot product provides the algebraic shortcut. Geometrically, A dot B equals the two magnitudes times the cosine of their included angle. In components, the same dot product is AXBX plus AYBY plus AZBZ. Dotting D with I hat makes every term vanish except dx. Since a unit vector has magnitude 1, D dot I hat also equals the magnitude of D times cosine theta x. Therefore, cosine theta x is simply dx divided by the magnitude of d. Before finding any direction angle, calculate the vector magnitude. The three-dimensional Pythagorean theorem gives the square root of dx squared plus dy squared plus dz squared. For the components 2, -4, and 1, the sum of the squares is 21. Thus, the magnitude is the square root of 21 meters, approximately 4.58 meters. The negative y component is squared here, so it contributes positively to the magnitude. Apply the same relationship to each axis. For x, cosine theta x is 2 over the square root of 21, giving 64.1 degrees. For y, the numerator is -4. The inverse cosine is 150.8 degrees, an obtuse angle, exactly as the negative y component suggested. For z, cosine theta z is 1 over the square root of 21, giving 77.4 degrees. Keep the component signs. Removing the minus sign would change the y direction angle to the wrong side of 90 degrees. Do not expect the three direction angles themselves to add to 90 or 180 degrees. Instead, return to the vector. Dividing d by its magnitude makes the unit vector d hat. From the relationships we just used, its x, y, and z components are cosine theta x, cosine theta y, and cosine theta z. Because d hat has length 1, the three-dimensional Pythagorean theorem says that the squares of those components must add to 1. Here that is 2 squared plus -4 squared plus 1 squared, all divided by 21. The result is 21 over 21. This is not another formula to memorize. It is the same Pythagorean theorem applied to a normalized vector. The vector magnitude is square root of 21 meters. Its direction angles are 64.1 degrees from positive x, 150.8 degrees from positive y, and 77.4 degrees from positive z. The negative y component correctly produces the only obtuse angle. The transferable idea is this: when a three-dimensional drawing becomes hard to interpret, dot the vector with each unit axis vector. Algebra can recover the angles without asking a perspective sketch to do more than it can.